You got your reads from the sequencing facility and you asked yourself the question, how good a job did they do? And to test that, you went into Tools and Services, FastQ Utilities, and under the pipeline, you clicked FastQC and added it to the pipeline, and you analyzed your reads that way so that you could see just what a good job your sequencing center did. This webinar is going to show you the results of the FastQC job that you submitted to BV-BRC. So let's go into our workspace, and I'm going to go into my home workspace. I'm going to navigate to the folder that has those jobs. There it is, the FastQ Utilities and FastQC. So I click on that, and there are a number of jobs here, each with this little checkered flag. For the NASCAR Formula One fans, it's an indication that the job successfully completed. So I'm going to click on one of those, and it's going to open the job, and it's going to tell me the job number, when it ran, and how fast it ran. And you'll notice what comes with it are two reports. These are HTML. This is the only part of the FastQ Utilities Service where you don't get any reads back. All you get is a report. And there's also a meta text file. So if you click on that and click on the view icon, it just tells you what it was that you ran. Now you can go back to the same location using the breadcrumb across the top. So click on that. We're back in the job. Now there are two reports here, one for each of the reads. These were paired reads. So there's 1 versus 2. Let's just look at one. So I highlight that. It populates the vertical green bar to the right with possible downstream icons. Let's click on View. And this is the FastQC report on the quality of your reads. First, it's showing you the base sequence quality. Things that are in the green are good. Things that are in the red are bad. So it's going along the position of the reads, which are going up to be like 100 base pairs. And let's see what it says here. It tells you that the sequence length was 101, what the percent GC is, how many sequences there are, and what it thinks the sequencer was. So it looks like the sequencing quality is pretty good. It dips down into slightly less quality when you get to the very end. Now, this is the per tile sequence quality. Well, you're probably thinking, what the heck is that? And what does it mean? This is looking at the flow cell from the sequencer where your organism was submitted. And if it's all blue, all of those flow cells are behaving well. When you see things like this, there's an indication that there might have been a few problems. That may be so, but this looks really good, so I wouldn't worry too much about it. And generally, if you see really poor quality here, they'll be like bright red, and they'll be like a whole streak across. So I think this is pretty good. Don't go back to the sequencing center and complain about these dots. You don't need to. Then when you look at the quality scores, this is the PRED score, and it's looking at the total number of reads versus the average quality score over the full length of that read. And actually, this is pretty much what you want it to look like. That looks pretty good. So another thing you don't have to complain about. This is showing you the percent of bases of each of the 4 nucleotides at each position across the reads. So looks like they're somewhat even, although it looks like they're more A and T's than C and G's. And, you know, that also depends on the organism too, right? So the percent GC content, you want this kind of distribution. There's the theoretical distribution, and your distribution matches that, so that's good. How many N's were found in these reads? And by an N, that's what's assigned when it can't figure out if it's an A, a C, a T, or a G. It'll stick an N in there. Looks good. They didn't find any. The sequence length distribution, they were all around 101, so that looks good. And then the sequence duplication levels, you notice that you get a little flag there telling you that there might be something to be concerned about. It's showing the distribution of the reads over the length of the sequences, and it looks like there's something going on here. But overall, things are looking pretty good. Overrepresented sequences, it didn't find it. So that's good. And looking for adapters, it didn't find anything major. So this is an indication of a good report. It looks good. But you may be asking yourself, so what does a bad report look like? So I'm going to go, I've prepared one here. Let's go back up, use the breadcrumb to navigate to the FastQC folder that I showed you before. You click on that, and this was a wastewater sample from the Frankfurt, Germany plant. So I'm going to click on that row. It's going to open this up, and this was just a single read file. So let's look at that. Let's click on the view icon, and it's saying, oh, the GC content is here. The sequence length varies a lot. Sequence is flagged as poor quality is 0, but these are the total number of sequences. But look over here along the summary. Look at all the warnings that are popping up. It's an indication that things are not looking good. Look at this one. Where the last one, everybody was in the green. Here we've got it in the lesser one and dipping down into the red. And also look, this is a mammoth. These things are big. It's 300 base pairs. The per sequence quality scores, there's some indication that the Fred score that this isn't so good, something they want you to be aware of. The per sequence base count, remember how those looked in the last one, those nice, clean, pure lines? This is showing that there's quite a mess, and it's got the warning flag up. The GC, oh my gosh, remember the last one, how that red line mirrored the theoretical distribution? And this one's all over the place. The N content, not a lot of N's, it was able to call them. And the sequence length distribution, look at that. There's a bunch of everything everywhere. And when you look at the sequence duplication levels, it looks like you've got a problem with that too. And overrepresented sequences. And it goes on and on and on. So there's a lot of duplications in there. And it was looking for adapters, but that doesn't seem to be a problem. You know, if it were me, if I was set on using this, because when I look at this quality here, I'm not wed to this sample. But one thing I might do is trim it if I wanted to go further with it. So we showed you an example of a good report, what it looks like when you should feel free to proceed and do your analysis with those reads, and a report that may want you to reflect and go back to the sequencing center and say, things are not looking so good here. And they may come back and say, your sample was somewhat degraded when you gave it to us. But anyhow, that's what we have here. Good luck in your analysis, and I'll see you at the next one. Bye.